Hello, my name is Tritsch. I'm presenting from a lab located near Frankfurt in Germany, and I want to welcome you to my session on exploring perceived WVD user experience. Thank you, Christian Brinkhoff, for inviting me to this awesome event. Now, let me share my screen. I'm a technical evangelist focused on virtual desktops and benchmarking, and I'm a proud member of several expert communities. At this point, I want to thank Christine Griffin, Freek Berson, and Dennis Gundarev for contributing material and inspiration. On the right, you can see today's agenda. At the beginning, you will learn about the criteria that define perceived WVD user experience. Then I will introduce you to the dashboard approach that is typically used in WVD production environments. Next, you will get in-depth information on the crash test approach, which is about building WVD test labs in pre-production phases with a goal to measure and compare user experience. This is followed by selected user experience test cases where I will walk you through the results of some WVD experiments I've conducted during the last months. Summary and conclusions mark the end of my session. Okay, let's dive right into it. I guess we all are on a journey to Azure WVD. We all are aware of the fact that WVD is not ready yet, and we don't know where exactly this journey is going to bring us. But there's one common theme across almost all WVD proof of concepts, and that's user experience. Over the last couple of months, I stumbled across some interesting user experience challenges, and as an intro to my session, I want to show you 4 examples. This full screen video dissolves, most probably due to network constraints. What you see is not an artistic effect, it simply annoys the user who's watching it. Here you can see some nice block boundaries or tiling, an effect that's typically caused by data compression. And you can see a lot of stuttering, despite the high frame rate that's rendered in the frame buffer. The next example is a loss of focus in an OpenGL application, an effect that can only be seen in a remote session. Admins are not aware of such effects, as there's no performance counter for that. And finally, here's a DirectX application that shows an error message due to the lack of a GPU. To explain the degraded user experience, we need to understand what's happening behind the scenes. In step 1, the WVD client connects to the WVD broker, user authenticates, and on click, the user is assigned to a host pool virtual machine with a predefined VM size. Windows desktop and application objects are rendered into the frame buffer of the VM, ideally with the help of a GPU. The graphics data in the frame buffer gets compressed and encoded into a video stream. This data gets forwarded to the remoting protocol stack. The remoting protocol stack sends the video stream from host pool VM to client device over the public internet. The WVD client decompresses and decodes the received video stream. Finally, the remote Windows desktop elements or the remote applications are displayed on the client screen. All these steps contribute to what is referred to as latency or lag. Bad user experience always happens when there's a problem in one of these steps. When looking at the network, it does not only introduce latency, there may also be bandwidth constraints or packet loss contributing to the overall network performance. But typically, latency hurts us most. The WVD experience estimator gives us a good indication on how much the network connection contributes to the latency. Here you can see the latencies from my lab to the different Azure locations. End users seem to have certain expectations when it comes to perceived user experience. I call this a tacit agreement or a silent mutual understanding of the service quality. And many times WVD admins have no idea about this. In essence, it's an agreement WVD end users expect from those who are delivering WVD as a service. But what exactly are the common criteria? La firma is the Italian term for a signature in a business contract, and I'm using it as an acronym for the individual WVD user experience criteria. L stands for logon time and desktop load time. A is for application load time. F, like perceived frame rate. I is image quality and compression artifacts. R is user input delay and responsiveness of graphical elements. M stands for media and graphics formats supported. A, session and application availability and resilience. There are two ways you can look at individual La Firma criteria for user experience. One way follows the dashboard approach, while the other follows the crash test approach. I will walk you through both and show you examples. The dashboard approach is typically used in production environments. It's based on observing or monitoring performance counters for alerting, automation, troubleshooting, and change planning. This means that Performance Monitor can still be part of this story. I used it over the last couple of months to investigate the details of the side-by-side stack for RDP that is used when you're connecting to a WVD session from a WVD client. You can find the side-by-side performance counters of each WVD session in Performance Monitor. The side-by-side stack for RDP is based on the Universal Rate Control Protocol. Here are some very interesting links if you want to learn more about it. A much more common and nicer way of looking at WVD performance counters is to use Azure Monitor and Azure Log Analytics. Thank you to Frank Burson for providing these nice screenshots. Let's start with the overview. What we can see here is the application groups, the host pools, the workspaces, and the user sessions. In the next screenshot, we can see the host performance. It's focusing on CPU, memory, network, and the disk resources. So this is the first view into real performance counters, but from the host perspective. If we go into a session view, we can see the user sessions. That's the number one on the left side. We can see the user time per process. We can see the processor time by process, and we see the disk I/O, which is very important for the performance of the Azure VMs. This is why we have a separate view on the disk performance on the right side. And finally, we can build our own queries using Log Analytics. You see there's a GitHub link that gives you access to everything that you need to build your own queries. So you can extend the logic if you want to view performance counters in your WVD environment. As you would expect, there are also several third-party products out there focusing on collecting and visualizing WVD performance data. Here are just two examples. Number one is Sepago Azure Monitor for WVD. You see the link down there. And the second one is ControlUp script-based actions. Again, there's the link, but we will also take a look at the individual products. Sepago Azure Monitor for WVD is a native Azure service, and it allows you to collect performance data, write it into a database, and then visualize the data in these beautiful graphs. So this is very powerful. It's definitely worth taking a look at it when you want to monitor your WVD environment. Control Hub, on the other side, they follow a more traditional approach. What they do is they establish an agent on each WVD host machine, and the agent delivers telemetry data or performance data to a real-time console. This real-time console receives this data every 3 seconds and it refreshes in this very short interval. So it's close to real time. And on top of that, you can dig into the details of each individual VM or each individual session that's running on the VM. Here, as an example, I ran a script that is behind one of my interactive sessions that I have opened. And it allows me to look into the details of my logon duration. So I can find out how long the Windows logon time took, the user profile load time, group policy, how long it took until the user init worked and the shell was started, the packages that were loaded by Apex, and all of that. And it gives me the total time that it took for this user session to get logged on. On top of that, there are control hub script actions that were developed specifically for WVD. Here in these screenshots, you see users that are logged on to a WVD VM, and then you are able to do things on right-clicking on the user. So on the left side, you see that you could log off the session or shadow the session. So the typical RDP things that you can do. But on the right side, you see that there are recommended actions that you have available for WVD that hook into the backplane. So this is based on PowerShell scripts and using the REST API that is exposed by WVD. And Esther Bartel is one of the developers behind those scripts, and she presented a session on scripting for WVD earlier today. Okay, let's shift gears now and look at the crash test approach, which is better suited for pre-production phases, such as design planning, migration planning, approval processes, and load testing. This approach follows best practices used in science or research. It comes very close to a classic physics experiment, and it goes far beyond performance counters. To be very clear, the goal is not to reproduce the reality. It's more about exploring individual aspects of a WVD session and the user experience using simulated workloads or synthetic users. The intention is to understand, predict, or avoid effects observed in the real world. Just remember the La Firma criteria. These are the ones that we want to observe. There are always three phases when running such a test. Number one is ask the right question, state a theory, and build an experiment. Phase number two is run the experiment and collect data. Phase three is analyze the data and draw your conclusions from it. Don't underestimate the effort it takes to build, run, and analyze such an experiment. This is how a typical WVD test lab setup looks like. It all starts with a user connected to a WVD session. In the session, we can run workloads that are simulating user interaction. This makes sure that the exact same user behavior is repeatable. The screen output of the physical WVD client goes to a frame grabber or video capture device that is connected to a screen recorder PC. This allows us to record the perceived user experience without influencing the performance of the client device. On a multi-session VM, we may want to add secondary users. We call them noisy neighbors. We all know that the perceived user experience of the primary user can be influenced negatively by a growing number of noisy neighbors. While running and recording a simulated workload, we are also collecting time-stamped performance counter data. As a result, we have correlated screen video and telemetry data. What looks so simple here may be really hard to build. From my experience, the time to build such an experiment is significantly longer than running the tests. Like mentioned earlier, building a WVD test lab has a lot in common with building a physics experiment. This is why there are no standard setups. The setup depends on the test case. Different WVD user experience criteria may require different WVD test lab setups. Here are some lab components I'm typically using. Some of them were created by community members. Number one on my list is the video capture device that converts the screen output that comes from the client device into a video data stream. My favorite capture device comes from a Canadian manufacturer called Epiphan, but there are many other such devices out there. Number two, for the video recording, I prefer to use the free OBS Studio, which is very popular in the gamer community. It not only allows you to record screen videos from all kinds of sources, you can also live stream them. An alternative recording software is Bandicam. Remote Desktop Analyzer was developed by some Team RGE community fellows in the Netherlands. It shows the remoting protocol settings and statistics in real time. There are many remote desktop clients in the market that can be used for noisy neighbor sessions. If only RDP is required, Remote Desktop Plus comes very handy, and it's scriptable. Full disclosure here, I'm a co-founder of Rex Analytics, and we started it simply because we didn't find adequate synthetic workloads, analytics tools, and telemetry data collectors in the market. So we had to build our own, and we give it away for free. And finally, I'm using lots of PowerShell when building test labs. Here's a screenshot of OBS Studio showing one of the synthetic workloads in a WVD session. Most of my screen recordings are MP4 videos in Full HD and 60 frames per second. Collecting performance data can be done with sophisticated tools, but the simplest way is using PowerShell scripts. This three-liner defines the CSV output file in line 1. In line 2, it collects 2 performance counters every second for 45 seconds. And in line 3, it exports the results to the CSV output file. Done. Now the trick is to run the synthetic workload, the screen recording, and this script simultaneously. This may require more scripts. After completing multiple sets of test runs, I can feed the collected video and telemetry data into Rex Analyzer, which is a side-by-side media player. You will see it in action in a couple of moments. This custom media player runs 2 video streams side by side, allowing visual comparison. In addition, it can overlay the animated performance data in those telemetry files that belong to the videos. This setup is extremely helpful when comparing perceived user experience. For example, it allows us to see the difference before and after optimizing a system, with or without a GPU, with or without noisy neighbors, or any other comparison you can think of. In essence, this setup helps people to compare things in an objective and repeatable manner. Okay, now it's time to walk you through a typical WVD test case, and it covers a question that I keep hearing again and again. What is the impact on WVD user experience when using a GPU-accelerated Azure VM? The theory is that user experience will be significantly better for graphics-intensive workloads. But how much better is it? What are the benefits of a GPU? If a GPU is present, the CPU can offload some of the application code. The GPU is optimized for taking care of some compute-intensive functions. Most of these functions can run in parallel, so the more cores the GPU has, the better it is. The CPU acts as a broker, orchestrating the tasks. Now, let's see how this can improve the WVD user experience. On the left side, which is blue, we can see an NV6 VM where the NVIDIA M60 GPU is exposed to the user session by group policy. On the right side in red, we see the exact same VM, but the physical GPU is not available to the user session. So it falls back to soft GPU, where the CPU emulates the GPU. You can already see the different WebGL rendering results. The water on the left side is way more realistic than it is on the right side. But let's see everything in action. Okay, we can see the difference in the rendering. Frame rate is much higher on the left side, the blue side, than it is on the right side. At the same time, the CPU load in the VM without the GPU is much higher. And we cannot deliver so many frames through RDP than we can with a GPU. So there's a significant difference between the two. Now we're looking at a DX11 application. The rest of the setup is identical. Again, the performance is very different between left and right. On the left side, you see that the animation is very smooth, even though the CPU load stays at less than 50%. The GPU load in blue is high as it shows the offloading. RDP delivers between 25 and 30 frames per second. When we zoom in, we see that 900, sometimes 1000 frames per second go to the frame buffer. This gives us an outstanding user experience. On the right side in red, the CPU is saturated at 4 frames per second. The CPU queue length is very high. One user can bring this VM to its limits, and performance simply sucks. The theory is confirmed. GPUs improve perceived WVD user experience significantly. Let's add some noisy neighbors to the story. The question is, how much do secondary users influence a primary user's WVD user experience in a multi-session environment? The theory is that we should see a difference when adding a fairly small number of power user sessions. Now, can a GPU help us here? And what is the price difference when using a GPU accelerated VM type? When looking at VM prices, we can see that the NVIDIA-powered NV6 is relatively expensive. But when using the new AMD NV4 V4 VM types, it's the same price range like the popular D-type VMs. When looking at the vCPUs and RAM, it may be even cheaper in a multi-user setup when using the NV16 V4 VM type. In this test case, we are not only running the 45-second application workloads in the primary user session. We're adding secondary user sessions running a power user persona. A persona runs much longer, like 60 minutes, generating a consistent load. This makes sure that all tests are fair. It's like your noisy neighbors are playing music at a consistent volume all night long. Before digging into the test results, let me show you what it looks like when 4 noisy neighbors are doing their job. User number 4 just started the applications, while users 1, 2, and 3 are consistently working. They have some background applications and one foreground application that they're interacting with. So this is the typical scenario. Now let's see the impact 4 noisy neighbors have on NV4 V4 VMs with and without the GPU being available to the user sessions. It's another DX11 application running in the primary session. Be aware of the fact that the 4 secondary sessions are running on the same VM. Both users start the application at the same time. On the right side, we can see the CPU load in red. It's at 100% because the CPU does everything, including the graphics workload. On the left side in blue, we can see that the CPU is around 50%, but the GPU takes a lot of the burden from the CPU. So it is at 100%. On the left side, we see a very smooth animation. Everything works nicely. The RDP frames per second are at around 30 frames, which is wonderful, so it's great user experience. On the right side, we have after almost 30 seconds, the first frame of the real application. So the user had to wait forever. Here is something that I want to point out. The primary session and the 4 noisy neighbors on the VM without GPU generate so much load that we can see gaps in the telemetry data. The values don't fall to zero, but there are simply not enough system resources to collect performance counters at this moment. Rex Analyzer clearly marks such gaps. Now, let's see the result when we have a GPU on both sides, but no noisy neighbor on the left and 4 noisy neighbors on the right. This time, we are running an OpenGL application in the primary session. On application start, we can see that everything runs smoothly on the left side in blue. When looking at the telemetry data, we can see that there's not too much going on. CPU is good, both in red and in blue. We see the spike on the blue side, but that's about it. The GPU is also not at 100%, but it takes forever until the application loads on the right side in red. Now it happens after quite a while, so again, the user will not be very happy about this result. What's most disturbing when looking at the red telemetry data, we don't see any indication why the application started delayed. But this is one of the La Ferma criteria, application load time. Only the screen video shows us this effect. For the next test, we're going back to the NV6 VM type with an NVIDIA M60 GPU. Operating system is still Windows 10 multi-session. Now we have 4 noisy neighbors on the left and 6 noisy neighbors on the right. Shouldn't make too much of a difference for the WebGL application in the primary session. Let's see. Okay, launch the application. Everything looks nice on the left side, on the blue side. It takes significantly longer on the right side, on the red side, even though there's not so much difference in the GPU load. But still, you can see frame rate is better on the left side than it is on the right side. And on the right side, fish are crawling compared to the left side. Again, the theory is confirmed. Secondary power user sessions have quite some impact on a primary user session, but power users are kind of extreme. Results are different when the noisy neighbors are task workers or only open Notepad. Let's move on to another test case. It's about the question if a WVD desktop can compete with a physical machine. The theory is that even with a very powerful WVD VM, perceived user experience may not be as good as with a physical PC. Without stealing any thunder, I can assure you that a WVD desktop easily beats an old physical Windows machine. But what about a modern PC? They all come with a GPU these days. Before looking at the results, I want to highlight the significance of latency again. Research suggests that the overall visual feedback delay should be below 75 milliseconds. Taking rendering, encode, decode, and display latencies into consideration, this means that the network latency should stay below 50 milliseconds, ideally even less. If we have significantly more than 50 milliseconds network latency, this is our bottleneck, producing bad perceived user experience. The first comparison shows a physical Intel NUC with an embedded Iris Pro GPU on the left and an IGEL UD3 thin client connected to our well-known WVD NV6 VM on the right. NUC data is in red, IGEL plus NV6 data is in yellow. There is no network latency for the NUC, but 30 to 40 milliseconds latency between the IGEL thin client and the NV6 VM. Both sides run smoothly. Telemetry shows that the CPU load is at about the same level, but the NOC renders as many frames as possible, which leads to a saturated GPU load in red. The remoting stack is smarter. It instructs the GPU to only render 60 frames per second, which keeps the GPU load very low and very efficient. The latency on the right only introduces some micro stutters. Let's use the same setup again, but this time we run the DX11 shading application. Due to the significantly higher frame rate, the WVD CPU load in yellow is higher than the NOC CPU load in red. The GPU is close to 100% in both cases, but we have a much stronger GPU on the right. We are seeing around about 350 frames per second for the physical NOC. For the WVD session, the protocol stack doesn't prevent the rendering at high frame rate, so we see up to 1000 frames per second. RDP delivers 30 frames per second. In this case, idle to WVD network latency doesn't really matter. Now I want to show you what happens when things don't work as expected. It's a misconfiguration that I've seen a couple of times. To be honest, it has also happened to me. Imagine you have users with CAD/CAM workstations under their desks and you want to migrate them to WVD and thin clients. You give them a nice NV6 VM, but you forget to configure the GPU settings properly. So in this test setup, you see a physical CAD/CAM workstation with an NVIDIA M5000 GPU on the left. Data is in red. On the right, in yellow, it's again an Igil UD3 thin client connected to a WVD NV6 VM. But this time the M60 GPU is not assigned to the VM by group policy, so it falls back to soft GPU, or better, no physical GPU. Big mistake. The result speaks for itself. Unfortunately, the users will blame the Igil thin client or the WVD desktop, but it's just what you get if you select the wrong WVD VM type or if you misconfigure the correct VM type. This theory was only partially confirmed. One result showed micro stutters for the WVD session, most probably caused by the 30 to 40 millisecond network latency. Another result showed a WVD session that outperformed the physical machine. But things may get really complicated when connecting to the wrong Azure location, selecting the wrong WVD VM, or misconfiguring important settings. If that happens in a new production environment, user expectations are not met. WVD test labs and build automation can help to prevent this. Whew, what a ride. You want more geeky stuff? Okay, here it is. Dennis Gundarev is the program manager at Microsoft in Redmond who is responsible for the RDP protocol and the RDP side-by-side stack. During a recent conversation, Dennis shared with me that he's using the Windows Performance Toolkit for protocol analysis. You can download the toolkit for free. Just check out the link below. The toolkit includes a recorder that collects telemetry data and an analyzer you can use to visualize the data. As a starting point, Dennis created synthetic workloads pretty similar to the Rex Analytics workloads, and he started testing. He connected to a WVD VM from another Azure VM acting as the client, effectively eliminating all network latency effects. In his WVD session, he launched the Windows Performance Recorder and started one of his synthetic workloads. This allowed him to collect all relevant data on the server or host side. Dennis was so kind to send me a couple of screenshots for this presentation, showing what the results look like in Windows Performance Analyzer. You can see the applications he used in his synthetic workload, the network traffic, CPU load, memory, storage, and so on and so forth. But that's not all. In addition, Dennis also started the Windows Performance Recorder on the client VM when the RDP connection to the WVD VM was established. This allowed him to analyze the data on both ends. So for example, he learned how much the CPU load changes on the client side when changing the RDP settings on the host side. There is no fancy screen recording, and it's all blood, sweat, and tears analysis of huge amounts of data collected in endless test runs. This is serious work following research best practices. All these tests also start with questions like, what's the amount of data that goes through the wire if I change this RDP setting? Or how can I optimize the protocol for Microsoft Office? The good news is that the toolset is available for you as well. So you can start running your own tests using the same methodology. Take a deep breath. This is almost the end of my session today. Here are some final words. If you have questions or want to learn more about one of the topics covered in my session, send me an email. When you are planning to build your own WVD test lab and want to use the free Rex Analytics modules, send me an email. My email address is wvd@drtritsch.com. And yes, I am a real doctor, but that's a different story. Let's come to the conclusions. Don't forget La Firma. I'll show you the criteria list again in a second. Don't even consider running your production WVD environment without monitoring. It simply won't work. Don't walk in the dark during WVD planning, design, migration, or proof of concept phases. Building test labs is tough, but it's worth it. And here is the promised recap of La Firma. Logon time, app load time, frame rates, image quality, responsiveness, supported graphics formats, and availability are the critical factors. Please listen to your users. This is it for today. I hope you enjoyed my session. Thank you so much for attending. Goodbye.